Good evening, everyone. So, welcome to Career Launcher. My name is Naveen, and today we will continue with our previous year question discussion of algebra. We'll be looking at Algebra 5. Some of the questions are as such, some of the questions are the data has been changed. Okay. So, without wasting any time, let's begin with our first question of the day. Let P and Q be the roots of the quadratic equation x square minus alpha minus 2x minus alpha plus 1 is equal to 0. Then what is the minimum possible value of P square plus Q square? So a question based on quadratic, and that too, it has to do with roots, right? Some of the roots, product of the roots. So the part that is asked, that is something that we have to somehow figure out how it is. Hold on. Right? So we have to come up with a particular way to get the value of P square plus Q square. So how can we do that? What is the best possible way? So what I'll do is I'll give you guys a couple of minutes. Let me know. Let's see how many of you can answer this. You guys have 2 minutes and 2 minutes only. Yeah, good evening, Aranya. No one? Okay. So can we say P square plus Q square can be written as P plus Q whole square minus 2 times PQ? Now, P plus Q is nothing but sum of the roots from here. So this is going to be sum of the roots is given as minus B upon A, where A is 1, the coefficient of x square. So we have square of this minus 2 times product of the roots. Now the product of the roots is given as C upon A. Here C is already minus of alpha plus 1. So this is going to be minus of alpha plus 1. So this will change to alpha minus 2 whole square. We can take out minus outside. So we will have 2 times of alpha plus 1 now. So this results in alpha square minus 4 alpha plus 4. Then opening the other bracket, we will have 2 alpha plus 2. That results in alpha square minus 2 alpha plus 6. Now, how do you find minima of a quadratic or a maximum of a quadratic? What you do is you try to make a perfect square from here. So what I'm going to do is I'm going to say this is alpha square minus 2 alpha plus 1. So this will give us a perfect square. So divided 6 into 1 and 5's sum. So this changes to alpha minus 1 whole square plus 5. So the minimum of this is going to be 5, the number that is written outside. So that becomes our minimum. So fourth option. So do please remember that if you have a quadratic of the form P times X minus Q whole square plus R, and if P is positive, you will get a U-shaped graph. So we say you will get a minimum. If P is negative, you will get an inverted U-shaped graph. That means you will get a maxima. What is that minima or maxima? It's the number that is written outside, which is R. And this will happen when the perfect square is 0. And that is supposed to happen when x is equal to q. P cannot be 0. If P is 0, it won't remain it won't remain quadratic at all, right? So we will remember this. Okay, let's move over to the next question. Now you were close. X plus 1 upon x whole square minus 3 times of x plus 1 upon x plus 2 is equal to 0. How many distinct real roots of the equation we are going to have? So since if you look at this, you have got biquadratic, as in x plus 1 by x is nothing but x square plus 1. And if you square it again, you will have x to the power 4. So real roots are going to be 0, 2, or 4. These are the only three possibilities, right? Because you have biquadratic equation, maximum 4 roots you can have. Since imaginary roots, they occur in pairs, so you can have 4 real and 0 imaginary, or you can have 2 real and 2 imaginary, or you can have 0 real and 4 imaginary. So how to go about such equations? So you can see that x plus 1 by x is common, right? We can write that as y or t or a, completely our choice. So the equation changes to y square minus 3y plus 2 is equal to 0. Now this can be factorized as y minus 1 into y minus 2 is equal to 0. This gives us y is equal to 1 or 2. That implies we can have x plus 1 by x is equal to 1, or we can have x plus 1 by x is equal to 2. Now, any number in this world plus its reciprocal can never be equal to 1. If you know that, you will save a lot of time here. Suppose we don't know that, so we will have to solve this. So this is going to be x square plus 1 is equal to x, or you will be getting x square minus x plus 1 is equal to 0. Now, if you try to find out its discriminant, this is going to be b square minus 4ac, which is going to be 1 minus 4, which will be negative. Since discriminant is negative, we will have no real roots here. Now, if I look at the second one, a number plus its reciprocal is equal to 2. That only happens when x is going to be equal to 1, right? If we know that, again, we will save a lot of time, or else we will have to find out this, that it will result in a perfect square. The same equation that we had previously, right? So this becomes x minus 1 whole square is equal to 0. So this will result in x is equal to 1 and 1. So since we are asked how many distinct real roots we have, so the answer is going to be 1. There is only one distinct real root when x is going to be 1. Right? Little time consuming depending upon how much you already know. Okay, next question. How many distinct positive integer valued solutions exist for this? It's a very standard question. You will see such type of question in previous year exams. You will also see this in a lot of mocks and a lot of tests that you guys must be writing. So some base to the power p is going to be 1 in one of the three possibilities. First, if the power is 0, right? Second possibility, if base is equal to 1 and power is anything, doesn't matter. Or the third one where people they forget is when base is minus 1 and power is even. Because minus 1 to square, minus 1 raised to 2 or minus 1 whole to the power 4, it will always result in 1. For in the case of odd power, it will not result in 1. It will become minus 1 in that case. So these are the three cases that you should know. If I look at the first case, so I can say here x square minus 13x plus 42, this should be equal to 0. We are talking about power being equal to 0. So sum is 13, product is 42, so 6 and 7. So x minus 6 into x minus 7 is equal to 0. So this results in x is equal to 6 comma 7. What is the base when x is equal to 6 or 7? That's not our concern. It should not be 0. right? If I put x is equal to 6 or 7, anyways, we will not be getting 0. Okay. Second, when base is 1, that will result in x square minus 7x plus 11, that is equal to 1. That means x square minus 7x plus 10 is equal to 0. So sum is going to be 7, product is going to be 10. It will happen when x is equal to 2 and 5, right? We can factorize this as x minus 2 into x minus 5 is equal to 0, or we will be getting x is equal to 2 comma 5. There is no repetition, so we get unique numbers. So anyways, distinct is asked, so we have to be careful. And obviously positive integers. We can't take irrational values. That is not allowed. And negative also. Okay. When x is 2 or 5, your base is going to be 1. What is the power? Again, that's not our concern. Power is 0 or minus 1 or 100. We'll still get the answer. Third scenario. When base is minus 1, that is x square minus 7x plus 11, this is equal to minus 1. That will result in x square minus 7x plus 12 is equal to 0. So this can be factorized as 3 and 4 because 7 should be the sum, product should be 12. So this is x minus 3 into x minus 4 is equal to 0. So this results in x is equal to 3 comma 4. Now we are not yet done. If base is minus 1, power should be even. So when x is equal to 3, our power will become 3 square minus 13 into 3 plus 42. If you solve this, this is going to be even. So no problem here, right? 3 square is odd, 13 into 3 is odd, 42 is even, odd minus odd plus even is even. Now when x is equal to 4, our power is going to be 4 square minus 13 into 4 plus 42, which is like or even minus even plus even, which will result in even. So now we can conclude and now we can be sure that our power is going to be even when base is minus 1. So we can see that 2 values here, 2 values here, and 2 values here for x, and none of them are repeated. So there are going to be 6 such values of x for which solution exists. Okay, let's look at the fourth one. A quadratic function f of x attains a maximum of 3 at x is equal to 1. The value of the function at x is equal to 0 is 1. What is the value of f of 10? If you remember, in the first question, we did discuss, how to find, when to find minima, maxima, what it is going to look like. So we'll be using this to solve. So since it says we are going to get a maxima means we are supposed to get a hill-like structure or inverted U structure, right? Because we are dealing with quadratic. So we can say that f of x should look like p x minus q whole square plus r, where p should be negative. So p is negative, that we are sure of. So we should not write minus p there. Okay. P will automatically turn out to be negative. Okay. Now it says the maxima is 3. That means r is going to be 3. At x is equal to 1, that would mean q is going to be 1. So we can improvise and we can say that the quadratic function is going to look like something like this. Now, what is the value of p? How do we know that? For that, we are given the next statement. The value of the function at x is equal to 0 is 1. So we are given that f of 0 is 1. That means if I put 0 instead of x, I will be getting 1. So if we solve this, we will have minus 1 square is 1. So p plus 3 is equal to 1, or this will result in p is equal to minus 2. See, p automatically turns out to be negative. So we do not have to write p as minus already. Now, since we have known what p is as well, we can finally say that the polynomial is minus 2 times of x minus 1 whole square plus 3. Now we are asked to find out the value of f of 10. Instead of x, we are supposed to put 10 there. So this is minus 2, 10 minus 1 whole square plus 3, which is minus 2 into 9 square, which is 81 plus 3. So this is minus 2 into 81, which is minus 162 plus 3, which is minus 159. Second option. Right now, correct. Okay. Next, it is given that a plus 2b plus 3c is equal to 12. What is the maximum value of a, b square, c cube if a, b, c are positive numbers? So this is a question based on maximum minima where we use AMGM logic, right? But I'll tell you today the shortcut to AMGM logic as well. So what you do is, you'll see what is the term given to you whose maxima you're supposed to calculate. Since we are asked to calculate the maximum of AB square C cube, let's find out the value of A for which this will happen. So first step, what is the power given to A? And total how many powers exist over there? So you can see that the total power exists is 1 plus 2 plus 3, which is 6. Out of those 6 powers, only 1 is given to A. So you will be writing 1 out of 6 into. You will be taking the sum that is given into. You will be writing down 1 upon the coefficient of A in the given equations. Coefficient of A over there is 1, so that is 1. So this is the value of A which will give us the answer or the maximum of this. Similarly, if I want to find the value of B for which I will be getting the maximum, this is going to be B gets 2 powers out of total 6 powers. So it will be getting 2/6 of the total sum as well. But since B's coefficient is 2, so the value of B is supposed to be 1 upon 2. Same logic, C gets 3/6 of the total power into the sum into coefficient of C is 3. So we should write 1 by 3. If we solve this, the value of A turns out to be 2, value of B also turns out to be 2, value of C also turns out to be 2. So A is 2, B is also 2, and C is also 2. So this is nothing but 2 to the power 6, which results in 64. So the good part about this particular approach is you know exactly at which values of every variable you will be getting maximum or minimum, whatever is asked. Using AMGM, we do not get to know that. I hope this part is clear. I hope some of you may have learned something new today. Okay, so this is a question which is a word problem based on maximum minimum logic, AMGM logic. So there are 2 ways to solving this. First is brute force. Second is, using equations. It is given that if the sum of lengths of 3 sides of a rectangle is 200 units, then what is the maximum area of rectangle in square units? So we are given that the sides of a rectangle are A and B. So if I consider all the 4 sides, I will say that there will be 2 A's and 2 B's. Now, which one is the length and the breadth? I don't know. Okay. Suppose A is the length, or maybe B is the length. We have no idea about that. It is given that A plus B plus A, 3 sides is equal to 200. So we need to find out area. Area can be calculated as A into B. And we are asked to find the maximum area. Maximum area would mean, I'm talking about first approach, which option is the maximum here? 5,000. So can we come up the product as 5,000 such that A into B is 5,000 and A plus B plus A is 200? ऐसा कर सकते हैं क्या? Can we think of such a combo of number? Say brute force. Obviously 5,000 you have to write as the product and then sum plus one more variable as 200. If you think about it, I can write A as 50 and B as 100 such that it is 5,000. So that 50, 100 and 50 is 200. It makes sense, right? So we are actually talking about a rectangle with the sides 50 and 100, such that the sum of three sides of this rectangle is 200 and the product is 5000. Second approach, if you are not comfortable with brute force, so from here, can we say 2a plus b is equal to 200? We are asked to find out the maximum possible value of a into b. So same logic as the previous one. Can we say a will take half of the total value? Why half? Because power given to a is 1 out of total power 2. So 1 upon 2. Since the coefficient of a is 2, so we should be writing 1 upon 2. So this is the value of a. For b, b also gets half of the total sum. Coefficient of b is 1, so it's going to be 1 upon 1. So this turns out to be 50 into 100, which results in 5000 anyways. Right? So brute force is applicable when you have no idea how to proceed, or if you have never seen that question, you can obviously look at the options and start from there. Neha, minimum will not be asked. Simple logic exists here, which says that if you have sum of two numbers, let's say a plus b is equal to 10. A into b की value. If I take a, see, a and b, they are supposed to be positive real numbers. Zero allowed nahi. So I can take a is equal to, let's say, 9.9999 and b as 0.00001, such that a plus b is 10. A into b is going to be 0.000099999. इतना छोटा हो सकता है. I can take a as 3 and b as 7. I can take a as 4 and b as 6. I can take a as 5 and b as 5. So what you will realize is a into b, if you look at the values, there can be infinite values possible for a into b, but the maximum value is going to be limited. आप 25 से ऊपर नहीं जा सकते, कुछ भी कर लो. Think of two numbers, positive real numbers, whose sum is 10, and we need to find their product. So maxima is kind of a fixed range, not range, it's a fixed value, it's a fixed place to what extent you can go. But if you talk about minima तो धीरे धीरे कम हो सकता है ना. If I take a into b as a as 9.999999 infinite times, and b as 0.00000 infinite times 0 and then a 1, sum abhi bhi 10 hai, but the product will be very, very less. So when sum is given, then the combo of the products 0 होता है minimum, so it's going to be greater than 0, and the maxima is going to be some value. Since product 0 की तरफ बढ़ेगा हमेशा, तो it doesn't make sense to ask minima, right? Maxima पूछने का sense बनता है. Okay, vice versa, if the product is given to you and if you're asked the sum, उल्टा अगर पूछ दे, then you will be asked minima of sum, because a into b is equal to 10. So I can take a as 10 नहीं लेते, थोड़ा दूसरा नंबर ले लेते, 16. A into b is equal to 16. Then we can have 1 into 16, we can have 2 into 8, we can have 4 into 4, we can have 1000 into 16 by 1000. ये भी 16 देता है. This sum is going to be 17, sum is going to be 10, sum is going to be 8, sum is going to be 1000.016. तो आप देखोगे क्या ना कि सम जो है बढ़ते चला जाता है. As in if I take a as huge number, बहुत सारे zeros, and b as 16 by that huge number, the product is still 16. But the sum will be that huge number plus a small number. So sum will keep on increasing कहां तक जाएगा? इंफिनिटी तक जाएगा, बहुत बड़ा जाएगा. But minimum sum is going to be limited. That's why when the product is given, you are asked minimum of sum. When the sum is given, you're asked maximum of product. I hope this part is clear. So minima के लिए भी we are going to use the same logic. जो हम कर रहे हैं ना ये वाला same logic लगाएंगे. Let's say if we have a question like that. We do have. It is given that a square b cube c is 108. Then what is the minimum value of a plus b plus c if a, b, c are positive real numbers? Like in the previous question, again, there are going to be two approaches. First, brute force. What you find here, a square b cube c to the power 1, there are a total of 6 powers, right? So you have to write 108 as some number ka power 2 into some number ka power 3 into some number ka power 1. And looking at the options, you have to take such numbers ki it should be integral, right? Because option says 1, 2, 3, 6 integral. The options are giving you a hint that don't think as 1 by 2 lenge or 2 by 3 or root 5. Think of basic numbers. So 108 is 27 into 4. 27, 4, 1. So from here we can say A is 2, B is equal to 3, and C is equal to 1 if I compare. So the sum of A, B, C is going to be 6. So common sense and looking at the way the powers are given. Second approach, obviously we don't know this. So standard approach. So let's say A plus B plus C is equal to K. Normally क्या होता है? We know what the value of K is. Right now we don't. So from here, can we say A square B cube C to the power 1 can be written as A gets 2/6 of the power, so it will be getting 2/6 of K. I'm not writing 1 upon 1 because coefficient of every variable is 1. You know? Power 2. Then B gets 3/6 of K. Power is 3, so here power 3. And C gets 1/6 of K. Power is 1, so power 1. So K is 2 plus 3 plus 1. So K to the power 6. 2 by 6 is 3. So this is 3 square. 3 by 6 is 2. So this is 2 square. And this is 6. Sorry, 2 cube over. This is given as 108. Iski value 180 given, no? So from here, can we say K to the power 6 is now 108 prime factorized. So you will realize it's 2 square into 3 cube into 1. And if I take that denominator to the other side, we will have 2 cube into 3 square. And 6 is 2 into 3. So let's increase the powers here itself. So we will have 2 to the power 4, 3 to the power 3. This is what we'll get. You know? This is 2 into 3. So 1, 2 goes here, another 3 goes here. So we have 3 cube into 2 to the power 4. So that's exactly what I've written. So this turns out to be 2 to the power 6 into 3 to the power 6 into 1 to the power 6, let's say. So can we say K is going to be 2 into 3 into 1, which is 6? We get the sum. So same approach, but reverse engineered. If we know the sum, it's very easy. If you don't know the sum, we will assume it. While solving it later at this stage, we will get to know it automatically. I hope this is clear. दो अप्रोच, दोनों से आपको सेम आंसर आएगा. Okay, next. Find the minimum possible value of y if x upon y is greater than 4 by 7 and it is less than 12 by 13, where x and y are natural numbers. So this is basically a question which completely depends on what do you know about when the denominator is 2 or 3 or 4 or 5 and so on. Completely उस पर डिपेंड करता है. all you need to do is know what 4 by 7 is. So 4 by 7 is 0.5714 something something. So you don't need so much. 2 digits, I believe, is more than enough. Okay. 12 by 13. What is 12 by 13? Now, question arises, how do you know this? Well, if you have already done arithmetic, in percentage topic, you have to learn fractions to percentage or decimal value and vice versa. So it comes from there. 12 by 13 kitna hota hai? 12 by 13 is 1 minus 1 by 13 and 1 by 13 is 0.076. So we can say that this is going to be 0.92. So we need to find a value which lies between 0.57 and 0.92 from a fraction where the denominator is going to be lowest. Y ko minimum karna hai, denominator lowest. So the lowest denominator we have is 2. If I put 2 here and a natural number, will I be able to get 0.57 and 0.92 ke beech? Well, actually, any natural number by 2 is going to end in 0.00 or it's going to end in 0.5. Neither 0.00 nor 0.5 lies within the range. So this is not our answer. Next smallest number is 3. So if I take a 3 here, any number by 3 is going to end in something 0.00 or it's going to end in something 0.33 infinite times or it's going to end in something 0.66 infinite times, right? So we can very clearly see that this is going to happen. This is the value that can come here. 0.66 lies between 0.57 and 0.92. So n becomes 3. Actually, 0.6666 infinite times is nothing but 2 upon 3. So x by y actually 2 by 3. Then only it will fit. Where y is the smallest. Of course, there are infinite values of y that we can have, but we need the minimum value of y. So we can see that in this question, we do not have any maxima, minima, or any inequality. We should know the value of 4 by 7 and 12 by 13. Now, if you're thinking that what if instead of 4 by 7, if we had, let's say, 43 by 73, or what if instead of 12 by 13, we had 125 upon 139, something like that, how to solve it? If you're going to get this in CAT, obviously you can use the calculator to figure out the value from here, right? So, do you guys have any question, any query? Anything related to preparation, your mocks, anything? No? Okay. Thank you, everyone. So tomorrow we'll be doing games and tournaments part 2. So we'll be picking up a round robin or a knockout tournament based set. So please make sure that you attend at the same time at 8:30 tomorrow. Okay. So please make sure that you subscribe if you haven't and like this session. Okay, this is all we are doing for you guys so that you can practice, or if you want to learn something, you can learn it here. Until tomorrow, take care. Bye-bye.